So, have you ever stopped to think about what happens when AI stops just, predicting the next word and actually starts to think? Well, today we're diving into a whole new kind of AI that doesn't just spot patterns, it actually reasons its way through problems. And believe it or not, this whole revolution starts with a surprisingly simple mistake, a tiny little puzzle that exposed a massive gap in how AI used to work. I know, it sounds like a trick question, right? Any kid could do it. But for some of the most powerful AI models out there, this was a genuine challenge. And the reason why gets right to the very heart of this incredible new leap in artificial intelligence. Now, it wasn't that they were bad at spelling. Actually, it was kind of the opposite. They were just so good at matching patterns that they didn't really read the word step by step. They just saw the RR as one familiar chunk and completely missed the final R. It proved they were missing a deeper, more methodical way of thinking. That's right. This tiny, almost silly error was so revealing it actually inspired a whole new class of AI. Project Strawberry became the secret codename for what we now know as the O series, models that were designed from the ground up to fix these exact kinds of reasoning failures. So how'd they do it? Well, the best way to get your head around this new approach is with an analogy you might already be familiar with about two different ways we all think. The designers actually borrowed an idea from the Nobel Prize-winning psychologist Daniel Kahneman. He argued that our brains have two systems. There's System 1, which is our fast, intuitive gut reaction, and then there's System 2, our slow, deliberate, logical thought process. And now, AI is being built in exactly the same way. And this is where it gets really cool. Your everyday chat models, they're pure System 1, fast, intuitive, and really just based on predicting the next likely word. But these new O-series models are System 2. They're slow, they're logical, and they're built for deep analysis, using a method called chain of thought, where they literally show their work as they go. This example just nails the difference. Give both of them a complicated wedding seating plan, with feuding relatives and weird photo requirements. The fast AI will give you an answer in seconds, but it'll be wrong. The slow AI, it uses thousands more of these so-called thinking tokens to methodically work through every single rule, and it gets it perfect. So the whole point is knowing which tool is right for the job. If you just need a quick email or some marketing copy, a fast chat model is perfect. But if you're trying to debug some really complex code or analyze a legal contract or solve a tricky science problem, yeah, you're going to want a reasoning model. Okay, so if these models are thinking more deliberately, how do they actually pull it off? Well, the secret is a fundamental change in how they use their computer power. It's a huge shift called inference scaling. See, for years, the goal was always just to train bigger and bigger models. But the new breakthrough isn't about training bigger, it's about thinking harder in real time. When you give it a difficult problem, it just dedicates more brain power to it right on the spot. And here's a little peek under the hood. The model automatically breaks a problem down into smaller chunks. Then it tries out different ways to solve it, and this is the key, it actually catches and fixes its own mistakes as it goes. It's a systematic, self-improving loop. And the way they're trained is completely different too. Old AIs were only rewarded for getting the final answer right. These new models get feedback on every single step of their thought process. They are literally learning how to think correctly, not just how to guess the right answer. But how can it be so sure its final answer is reliable? Well, it doesn't just trust its first attempt. Instead, it comes up with several different potential solutions. And then it basically takes a vote. The answer that appears most often across all those different lines of reasoning is the one it chooses as the most trustworthy. It's a clever technique called self-consistency, and it's fantastic for filtering out mistakes. So, a whole new way of thinking, self-correction, majority voting. Does all this stuff actually work? Well, let's just say the results are pretty staggering. Let's look at the very first model, O1. On benchmarks for things like competitive math, it scored over 83%. On really tough coding problems, it hit the 89th percentile. And look at this, on a test of PhD-level science questions, it actually performed better than human experts. And things are moving unbelievably fast. The very next model, O3, just blew those results out of the water. Competitive math jumped from 83% to nearly 97%. That PhD science score? It went from 78 to almost 88. The improvements are just enormous. But there is one number in all of this that represents a truly massive milestone.
and that number is 87.5%. That is the score O3 got on a test called ARC-AGI. It's designed to measure pure abstract reasoning, the ability to learn new skills completely from scratch. The human-level score on this test is 85%. For the first time ever, an AI model has officially surpassed it.
Now, this isn't just about acing tests. This kind of reasoning power has huge, real-world consequences. But, as we're about to see, it also comes with a hidden cost.
We're talking about AI that can analyze dense legal contracts, help doctors make diagnoses, allow robots to make smart decisions in totally new environments, and even design and fix entire software systems. The potential is nothing short of transformative.
But you've got to ask yourself, right? All of this extra thinking, this inference scaling, what's the catch? And here it is. Every single one of those reasoning steps, every simulated strategy, every internal vote, it all has a huge computational and energy cost. And unlike training a model, which is a one-time thing, you pay this price every single time you ask a hard question. For really complex problems, that cost can scale up almost without limit. So that leaves us with a critical question for the future. We're building machines that can genuinely reason and solve problems at a superhuman level. But as AI gets better and better at thinking, how do we manage the enormous and frankly ever-growing price of its intelligence?